Now let's take a look at what the probability that the system operates only if at least one computer operates. Okay? So if one computer operates, the system operates, what's that probability? Well, let's think of the possibilities of those computers, those 4 computers operating. None could operate, 1 could operate, 2, 3, or 4 could operate. Okay? And we want to know what's the probability the system operates if at least one operates. That would be all of those possibilities. Okay? And again, we've done this before. Enumerating all those could take us a while. Okay? And it could take even longer if we had more computers up there. Okay? So what we can do, use the rules of complements to find what's the probability that none of them operate and take the complement of that. Okay? So what's the probability that none of them operate? That means that computer 1 doesn't work. Okay? And computer 2 doesn't work. The complement of computer 2 works is doesn't work. And computer 3, complement. And computer 4, complement. Okay? This gives us the probability that none of those computers work. And we need to take the complement of that to find this. So we're going to take the complement of that whole thing. Okay? So now, to find that probability, that would be 1 minus the probability of what's in here. Computer 1 complement and computer 2 complement and computer 3 complement and computer 4 complement. Okay? These are independent of each other. So we could say that's equal to 1 minus the probability of C1 complement times the probability of C2 complement times the probability of C3 complement times the probability of C4 complement. Okay? That's equal to 1 minus the probability of C1 complement. Well, here's C1, 0.88. Therefore, its complement must be 0.12. The complement of C2, here's C2, the probability of 0.78. So its complement must be 0.22. C3 complement, the complement of 0.92, which is 0.08. And C4 complement would be 0.15. Okay, we worked this out. That is 1 minus 0.000317, or 0.999683. So what's the probability that the system will operate only if at least one computer operates? It's quite high, 0.999683. This is a parallel system. Okay, so let's look at this. Here are 4 computers in parallel. And what we say here is that to get from here to here, we just, whoops, I wrote that wrong. We just have to get through one of these to get to the other side. Okay? That is, these components are in parallel in this system. If only one of these things has to work, the probability goes way up relative to a series system. Okay? Remember, the probability of the series system that we just did was roughly 0.5. Okay? Here, the probability that this system works, 0.999683. A parallel system, the probability that a similarly designed parallel system operates is much greater than a similarly designed series system.